Well, hey, Algebra 2 class, this is section 4.2, and it's a contrast between the vertex form and the standard form. Section 4.1 was all about the vertex form. We had a times x minus h squared plus k, where hk was our vertex, and a is what changed the shape. Well, now we have the standard form, ax squared plus bx plus c, the same a. I mean, literally, it is the same number. If you have a 3 right here, if you turn this into standard form, it will be a 3 right here. They are the same value. They both affect the shape in the exact same way. HK moves this thing exactly horizontally and vertically. B and C, they also move things around. They don't change the shape, but they don't move things around in a very predictable way. At least it doesn't seem to be at this point. Maybe the exception is C. C is the y-intercept, so C will move this thing straight up and down. But B moves things a little bit differently. So here is our ax squared plus bx plus c. If a is 1, we can see it's our normal standard parabola. But if b is changed, you can see how this moves back and forth a little bit, kind of around that y-intercept. If I move the y-intercept down something like this, we can see that b just kind of rotates it right around there. But the shape is not changing. The shape only changes when you change the a. Right? So that's how that's how the a, b, and the c work together. Sometimes it's a little bit more difficult to figure out how the graphing works. So let's jump over to the notes. Actually, let me move down just a little bit and put some notes in right here for you. If you want to find the vertex of this, there is no h and k that you can see. So there's a formula for this, and I'd like to be able to explain why the formula works, but it would take some calculus to really show a great idea how it works. Let me just give this to you, that h is opposite b over 2a. That's how you find the h value of your vertex. And the k is what you get when you put h back into the equation. So that's that. So what we're going to do, and you can pause that to figure out what that says. But now let's go ahead and do problem number 1. So we're going to find all these different features, and we're going to have to start with the vertex. I'm going to make a note here that a equals b equals c equals right from my ax squared plus bx plus c. I can see that my a is the number that multiplies the x squared term. That's a -1. B is 6, and c is 3. So I know this thing opens down because a is negative. And furthermore, that means if you move over 1, you do what the a says. If you move over 1, the a is -1, go down 1 on each side. If the a is 3, go over 1, move up 3 on each side. If the a is a half, move over 1, go up a half on each side. And those 3 points, the vertex and those 2 other points, should be sufficient for you to figure out how the curve works. And I'll demonstrate that in just a moment when I start graphing. So the vertex is hk, and the h is opposite b over 2a. Opposite b, b is 6. 2a, a is -1, so I've got -6 over -2, which is a +3. Great, so h equals 3. I'm halfway to my vertex. Now I figure out what k is, and k is what you get when you put h, 3, back into the function and evaluate it. Careful with this. This is not a -3 squared. It's a 3 squared made negative. Order of operations say you've got to do those exponents first. So this is 3 squared is 9 with a negative. So this makes -9. 6 times 3 is 18 plus 3. -9 plus 18 is 9, plus 3 is 12. So now I have my, not eraser. I have my h and my k, so I can build my vertex. Vertex is 3, 12. Great. Now, before with these other ones, didn't we do the axis of symmetry first? We did the x equals whatever the axis of symmetry is, and we knew that that value was the h. Now we have to work backwards. We know the h, we can create the axis of symmetry. If I know my h is 3, that means my axis of symmetry is x equals h, or x equals 3. So I know my vertex, I know my axis of symmetry. Let's go ahead and graph this thing to confirm that this opens down. Oh, rats. It doesn't look like I'm going to have enough room to go up 12. I'll just make each unit worth 2. So x equals 3 is my axis of symmetry. And now the point 3, I'll make each of these worth 2. So the point 3, 2, 4, 6, 8, 10, 12. There's my vertex, 3, 12. And now my a value again is -1, so I'm going to go over 1, down 1. Because the scale is 2, I go over 1, down 1. Looks like a half, it's not, because each of those marks is 2. Over 1, down 1, and those are enough. I'm just sketching this. If I want a really nice, precise graph, I'll grab a calculator or decimals, right? But this gives me an idea of what this looks like, and I sketch that in, and I have my parabola graphed. Great. So what kind of minimum or maximum is this? Well, clearly this is a maximum value. There is a maximum value of which there are no values higher, and it is a maximum, and the max or max is the k value, right? So this is a max equals, what is my k? It's 12. My max equals 12. Domain, is there any restriction on what I can put in this function? No, quadratics don't have restrictions like that. You can put anything you want in the box and do all the squaring and stuff and get something else. So the domain is all real numbers using my integral notation from -infinity to +infinity. And the range, I know that my range is nothing higher than 12. 12 is the upper limit. So y is going to be less than or equal to 12. And if you want to give that a shot with there's the bell. Hang on, you're almost done. -infinity up to 12, including 12, and not including that. So, and again, as I mentioned before, I'm going to put these in here always. If you on a quiz or a test just write this or this, I'll give you credit.
Zach Reiser to the high school office.
This right
Zach
here,
Reiser.
if you get these right and try these and get these wrong, I'm probably not going to worry about marking it wrong. I want you to try, but understanding it is the key. So that is that for that. Let's try problem number. Let me think. I'll do problem number 3 for us because this is very similar to that. This one, problem number 3, is where we need to. Oh, you know what? Converting. I'm not going to do this one. I don't think it'll take me too much time on the video. It's pretty in depth. There is the notes are pretty well worked out, so I think you're good there, as well as the notes for this one are pretty well worked out. So I guess that's it. Let me know if you have any questions on these. I hope that what we have done right here is a nice bit of work for you. If you have any questions or thoughts, give me a holler.